Find the acceleration of this block, which has a mass of 7 kilograms, down this frictionless hill. Here's what we have to do. We need to figure out, okay, which way is this block going to accelerate? It's going to accelerate down the hill. It's not going to accelerate in the y direction, which is where normal and gravity perpendicular forces are. We know that the normal up and gravity perpendicular would have to be equal to each other because in this direction, everything is balanced. But it will accelerate down the hill thanks to gravity parallel, since there's no friction. And we know Newton's second law says all of our forces added up in the direction of acceleration, which happens to just be force of gravity parallel, equals the mass of the block times the acceleration of the block, like so. Now we're trying to find the acceleration of this block, so we just have to divide the mass over to the left side. I get force of gravity parallel over mass equals A. Now the equation for force of gravity parallel, we've already learned that. That is the sine of the angle of the hill, which is 35 degrees, times the mass of the block itself, times g, which is 9.8 meters per second squared. We divide that by mass, and that will give us the acceleration. Now we know the mass of this block, it is 7 kilograms, but something which is kind of interesting is we actually don't need the mass of the block. The mass of the block will cancel. So it doesn't matter if the block is 7 kilograms or 150 kilograms, it's going to have the exact same acceleration down this hill. And when I plug sine of 35 and times 9.8 into my calculator, what I will get is an acceleration of 5.6 meters per second squared.